Day 23, LAN party. As the historians wander around a secure area at Easter Bunny headquarters, you come across posters for a LAN party. Sick. Why is... Oh god, is LAN party linked? Like, is this gonna be... Oh, it's a Wikipedia article for LAN party. Oh, am I old? Does that mean I'm getting old? I loved LAN parties, dude. Oh man, oof. That hurts to see it. There's a link there. Maybe you can find it. You connect to a nearby data link port and download a map of the local network, your puzzle input. The network map provides a list of every connection between two computers. Okay. Okay. So here are each computer. They have a name that's like 2 letters and a hyphen. Each line of text on the network map represents a single connection. The line KH to TC represents a connection between computer named KH and the computer named TC. Connections aren't directional. TC and KH would mean exactly the same thing. Cool. Do they both show up, or do I just have to infer that if I see this one, I also see the next one? So KH-TC does show up. TC-KH does not show up. Okay, so I'll have to find that myself. That is fine. LAN parties typically involve multiplayer games, so maybe you can locate it by finding groups of connected computers. Start by looking for sets of 3 computers where each computer in the set is connected to the other 2 computers. In this example, there are 12 such sets of 3 interconnected computers. Oh, okay, so AQ is connected to CG, it's also connected to YN, and these 2 are connected to each other. Okay, fine. Yeah, I've seen problems like these before. There's like network topology stuff, graph nodes, stuff like that. If the chief historian is here and he's at the LAN party, it would be best to know that right away. You're pretty sure his computer name starts with T, so consider only sets of 3 computers where at least one computer's name starts with T. That narrows the list down to 7 sets of 3 interconnected computers. Okay, all of these start with T. Find all of the sets of 3 interconnected computers. How many contain at least one computer with a name that starts with T? This doesn't seem that bad. This doesn't seem that bad at all. Oh my god, thank you so much. Transmission to ground. Transmit to ground? How am I supposed to pronounce your name? TX2GND in the YouTube chat. Thank you so much for the super chat. I appreciate that. Day 23. Cool. Example, input.text. I'm going to grab this from the website. There's a lot here. Cool, there's our example input. We'll grab the real input.text next. And I'm gonna unshare for that. We are left with a directory with 2 files in it. We have 32 lines in the example input and 3,380 lines in the real input. So yeah, we better get this algorithm working. Yeah, let's go. That's right. We're gonna go. So we have to figure out each connection that has 3 connections. So I already have a bunch of different ideas, like I'm picturing graph structures and nodes and connecting them and walking through it and all that stuff. But I don't think we need to get that complex. I think we just need a cache, associative array, where the key is the name of a node and the value is every single node that it is connected to. We don't have 2-dimensional data structures in Bash, so it'll just be the name of it with a space to the right of it, or a space to the left of it. So we'll just separate them by spaces so we can break them apart when we need to. We're gonna preemptively pull in vardump because I know I'm gonna use it. Vardump, in case people are wondering, is just a really simple program I wrote to dump a variable in Bash. It's available on GitHub. You can go check it out. I make sure to comment my code very nicely and even put in some notes and stuff here. So yeah, if you want an example of like what my code looks like when I actually take the time to edit it and make it look nice, this is a pretty good example of it. Let's see. So what are we doing? We have, let's just jump into it. Part 1. So our input is a list of words. While read -r line do done echo line. And what does our input look like? It looks like name comma or name hyphen name. So we can set the inner field separator to hyphen, and then we can read 2 things. Let's do A and B. So we'll have, node A, and it's a, bidirectional, to node B. So we're gonna rewrite the output to look like that. Okay, cool. let's store all of our connections. This is a hash map effectively, and we will say connections of $A will push B into it. And we'll push A into B and B into A. Now we don't have push and we don't have nested data structures. So what we'll do instead is we'll do a space and that. So we'll construct a string and we will append it. So it'll be a space separated list of all possible connections. We will get duplicates here. This is very important. We will have duplicates, so we'll have to go through and normalize this data. But that's okay. Let's do a var dump on connections just to get an idea of what we have. So here are the connections we have. Node VC is connected to these 4 things. Node AQ is connected to these 4 things. We might not actually have dupes. I don't know if there's a quick, easy way to look for dupes, but I could theoretically imagine a situation where we do have dupes. You know what I mean? Let me do something a little bit naughty here. TD to YN. Let's do YN to TD. Let's just mess with this. There we go. Okay. So yeah, this will be connected to TD. So if we get unnormalized data in, we will produce unnormalized data out. I don't know what Eric is going to give us, but we can still just go through and normalize it. So a user asked about the map function. We don't have a map function, but I will show you instead what we can do. We're gonna overwrite it. So for key in connections, we're gonna loop over all keys of that associative array. Done. Get the value out of it, which is the connections at key. And then we'll need to load every value into a new associative array to dedupe the keys. We're just gonna make a new set here. Just call it, oh, I love C. C is probably one of my favorite languages easily. It's always Bash, C, and Rust for me. We have to loop over each thing in value, and they're separated by spaces, so we can read value into an array. Then we can loop value for value in values. Done. Now we just need to take the, now we need to make a string of it. We need to just stringify the keys of C. There we go. And then we're going to write that back into connections. So connections at key equals a space and then $S. This might be a little confusing. All we did is we looped over each one of these. We put this into an array of 4. We push them into an associative array so it'll filter out any duplicates, and then we're going to write it back as a string. So when this is done, we will have filtered out duplicates. Now, this might not look like it did anything, because I don't think there were duplicates in there, but I could understand, I could think of a world where there would be. So we're just going to go ahead and filter them out. Yeah, so this didn't do anything. But if we were to, let's go manually put some duplicates in. So I'll print it twice, before and after the duplicate work. I'm going to go manually put some duplicates in here by doing YN to TD, which is the reverse of the one above it. So yeah, as you can see, this one has duplicates, YN, YN, and this one has TD, TD. This one filtered those out. So we've normalized the data. Again, don't think it was necessary, but I don't want to have to deal with weird bugs later down the road. So that's why we approached it like that. Cool, so what do we have to do? We have to go through and find all of the ones that have 3 connections. So the way we can do this is we know that VC is connected to these 4 things. We have to check. We have to loop through each one of these. So VC, AQ, and then we have to check, is AQ connected to UB? Because if AQ is connected to UB, we have a try. If AQ is connected to WQ, we have a try connection. If AQ is connected to TB, we have a try connection. If UB is connected to WQ, so we have to start at this element and then count all the elements to the right of it and check if they connect, because if they do, then we have a try connection. So we need 2 for loops. We need an I pointed here and a J pointed at the next element that loops up here. Then I points here, J points here and here. Then I points here and J points here. So that's how we do it. So look for all triply connected nodes. So here's what we're going to do. All right, so for key in connection, so we're going to loop this again. Done. Okay, so we have for A in connections, we'll call it A. We'll do A, B, and C. We'll read all of the neighbors out of it. These are our neighbors. For, we need the neighbor's length, don't we? Len equals neighbors. Cool. Yeah, man, dude, good luck to you. I love it. Raylib is so cool. As a library, I think it's just beautiful, and I want to make a game too, and it's a ton of work. And yeah, I mean, you know how it is, like, life gets in the way, man. It's brutal. But yeah, it's still fun, so, oh man. Now I'm thinking about game stuff, dude. Yeah, I have so many fun ideas for one. I equals 0. I less than len. I plus plus. Do for j equals I plus 1. J less than len. J plus plus. Do. Done. So B is what is at neighbors spot I. And C is what is at neighbors spot J. So now here we have A, B, and C. We know A, B, and AC. Check BC. So hopefully that makes sense. If we're here, we have 3 variables that are each different computer names. We know that A is connected to B. We know that A is connected to C. We have to check if B is connected to C. If B is connected to C, then we have a try configuration. So in order to do that, we can do it one of 2 ways. We have to look at the connections for B and see if C shows up in there. So we can do this. This is going to be gnarly. If C, so if C is equal to, no. I have to remember how to do this. I have to think about the way I want to do this. There's a couple ways to approach this. If connections at B, these are all the connections that B has, we need to check if C is inside it. And the way we can do that is we can look for a space C inside it with a star here and a star here, because we don't care what comes before it or after it. So we're just going to look for that exact string match in there. If that's in there, then we have a triple connection. Isn't it I less than? We're going to find out. I could totally be off by 1. We'll see. So now we have a triple connection. So we should store a list of the triple connections. We will also have to normalize this, but that's okay. So we'll have to normalize this, but we'll worry about that when we get to it. We'll just push the data into something called all, which is an array of all the connections. So inside here, we'll give it A, B, and C. And then that's it. Let's just var dump all. Whew. Yeah, that's what we'll see. All right, let's go ahead and run this and see what we get. All right, so here are all the triple connections we see. VC, AQ, WQ, but I think what's going to happen is we'll also have AQ, VC, right? AQ, VC, WQ. Yeah. Okay. So now we have to normalize this list because of the ordering here. We could sort A, B, and C and force it to be that way. I don't know. I can just pipe out the sort, obviously. I'm trying to think of a pure bash solution for doing this, for normalizing this data. Is there a way we could sort it in a way that makes sense? So I think if we have this and we loop over the keys, when you loop over the keys of an array, are they always in alphabetical order? Well, no, that doesn't look like it. So no, they're not. That doesn't help us. How would we get sort? If I have to pipe out the sort, I have to pipe out the sort. It's not the end of the world. Yeah, how would I sort this and normalize it in a way that makes sense? Let me think about this. Let me think about if that's even possible. How many dupes do you expect? I don't know. I don't know how many I expect. For right now, I'm having a connection. I'm having all three connections. So like, I mean, mathematically, I could probably figure out a number I expect. Like, there's 36 here. I wonder if there's like 12 real connections and... Oh yeah, hold on. There's 36 here and there's 12 real connections, so 3 times as many. I could probably do something with that information. Yeah. I'm gonna do some testing. You can't just compare like A less than Z, right? Can you really do this? I can just sort them this way? That's crazy if you can do that. That's wild if that's the case. Huh. That's so funny. I could implement my own sort function. That seems excessive, doesn't it? That's crazy, though. That's really cool. I didn't know that was a thing. Do I really just want to implement like some sort of sort? I really don't want to. Yeah, apparently Bash can just compare strings. That's so sick, though. That's so cool that actually is the case. Let me think if there's a nicer way of doing this. Well, we learned last time we can touch files and then just glob them, and we'll get them in a sorted order. I know. I lament not having a sort, which is built into some shells, but I don't have it. Yeah, this seems silly. I should just pipe out to sort, because it's pretty easy to do this. All right, how can I do this? Okay, that'll sort them. How do I read this back in? Is there a clean way of reading this back in? I think I can. I can just do... yeah, okay. Part 1. Sort them by name to avoid dupes. Okay. We'll have to define something called key, and that's fine. So to sort them by name, we will do a printf of variable, new line, variable, new line, variable, new line, pipe that to sort, store this as a variable, sorted equals that. Cool. And now we have them separated by new line, so we can just say key equals, what's a good way to do this? Sorted turn new line into comma. Let's try that. Where do I run it? There we go. All right, well, that looked pretty good. 46. Let's get an idea for what the keys look like. Okay, so this one's clearly empty, so that's not great. I must be doing something simple here. I'm not writing the values here. That's it. A, B, C. Easy enough. There we go. Cool. So what was the length of this one down here? We'll do a verbose to var dump. Length of 12. Okay, cool. That's what we wanted it. Let's see. Format a JSON, why don't you? I have thought about writing a bash to JSON converter. Literally take a JSON structure and turn it into its bash things, and then take bash and convert it to JSON. Converting a bash object to JSON is way more approachable than doing the opposite, because the opposite would break on so many different things. But because we don't have nested data structures in bash, so representing it any further than that would be very difficult. No. Printf args, yeah, I caught it. Yeah. It's always a stupid bug. It's always a stupid bug. Luckily, my hunch just kind of tells me where to go, so I just trust my hunches. Cool. So we get 12 there. Awesome. And now we have to check to see, we have to find the ones that only have a T somewhere in it. Can you pipe JSON output into declare-a? No, no, you can't. Well, I mean, you could, but who knows what's going to happen if you do that. Cool. We have all the triples. Find the ones that start with T. No, I don't want to implement it this way. Let's filter out the ones that don't start with T, because we don't care. No, we do. Never mind. I do want to do it this way. Find the ones that have at least one computer whose name starts with T. Okay, that's what I should make sure I reread exactly what it was. So declare T. We'll just say T equals new array, and we'll push into this, and this will be all of them that contain T's. Cool. YouTube not only eats messages, it holds them for 10 to 15 seconds. Dude, I don't know why it does it that way. I'm sorry that's the case. It seems like Twitch is more of the Wild West when it comes to chat messages. What are we doing here? Now we got to find all the ones that have T in them. Okay, we have to loop over the keys in triples. We could, what do we have? Name, comma, name, comma, name. Yeah. Let's just read them into an array. They're separated by commas. Read the key into an array. Now we have an array called computers. For computer in computers. Do done. If computer equal T star, meaning it starts with a T, then we will push the entire thing into the T array, and the entire thing is the key into the T array, and we will continue. But we have to go up to the second continue, so we have to continue 2. We have to break out of this loop. I think that's it, right? And then echo when we're down here. var dump -v t. What am I doing wrong here? Why is it yelling at me? Didn't close this. Okay. I think this is right. I like to know if someone is doing advent of code without using code, like they just crack out a notepad. Hey, some people are doing that. I know some people have solved some puzzles literally by hand. Some people are using Excel to do it. Someone did it in like Minecraft. It's kind of wild. If I ask a stupid question, what is the bracket? This is just how you handle arrays in Bash. So this just means every element of the array. So if it's a indexed array, this gives you every value. If it's an associative array, it still gives you every value. If you put the exclamation mark in front of it, it gives you every key. It's sort of like an iterator, you could think of it this way. So this will just loop over all the keys in this associative array. Let's go ahead and run this now. Okay, cool. So now we end up with this array. Here's all the triples. And, okay, yeah. Here are all the triples that we found with a length of 7. And according to this, there are 12 interconnected computers of 3, and there are 7 that are there. So we're getting exactly what we should be getting. So if we run this against our real input, I'm going to go ahead and take out some of these prints because it seems like an awful lot. We just need to say found the length of t. So we need to get the length of the array, use a pound sign here. Found possible computer clusters. I don't know what to call them. Okay. So now we're just going to crush through this data. I didn't put any sort of debugging, so if it runs for more than like 30 seconds, I might stop it and we'll just, put some prints in there and kind of see what's going on. Because hopefully this algorithm doesn't take too long. All right, we need more debugging. This is not useful. Echo read all connections. Echo remove duplicates. Echo find all triples. Echo find all triples starting with T. Yeah. Okay. Okay, so it looks like it's the logic to find all triples that might take a little bit of time. There is a lot to peel through. There's what, like 1,700 things to list through. And for each one, we have to go in this many and then this many in, and there's a lot. There's absolutely a lot. So we might need to find a better way of dealing with this data. But we'll get to it when we get to it. I've used Linux for my daily driver for over 10 years, and there's still so much you do that I don't understand. Kudos, mate. Yeah, I just know Bash super well. That's like, thank you. I appreciate the compliment. But yeah, I just got really good at Bash for no reason. So that's where I am. Okay, I want to get an idea of how slow this is. So we're finding all the triples. We are piping to sort every time. That could technically be slow. Echo A equals A. Echo B equal B. We'll just get an idea of how fast this is going. Okay. Pretty fast. Not the worst thing in the world. Do I use LAN anywhere else? I don't. Let's get the length of connections. I equals 0. Do a nice little I plus plus here. Change this to I equals 1. Printf. Now let's just echo I out of len. That doesn't seem right. Oh, we're overwriting len. Yeah, that's okay. We'll just call this clen. That's not even updating at all. Oh, we use I in the loop, don't we? Yeah. Wow, I need a better way to do this, don't I? Yeah. I'm reusing variable CI, we'll call it. Okay. Found 1437 possible computer clusters that start with T. Hey, that's not too bad, right? Let's take a look and see if this is correct. You guys ready? Moment of truth. 1437. Let's go. Let's go. Let's go. That's the right answer. 1 gold star closer to finding the chief historian. Easy. GG. Part 1 down. Whew. Scared of what part 2 holds in store, but so far we were able to do that, and it only took some time, so that's cool. Thank you, everyone. Thank you, everyone. Nailing it. Nailing it. Let me show you real quick. Let me show you. Let me show you what this would look like. So if we were to use the example input, that's what the example looks like. If we were to run bash minus x, get ready for this. It shows every single command that bash ran. Every single command. So you can quickly identify bottlenecks and stuff. Like it'll literally show all the math that's being done, the loops that are being done, what's set in the variables, what exactly it's printing to the screen before it prints it. So you can kind of identify like hot code paths this way pretty easily. So bash minus x is super useful. You can also do set minus x inside of your bash script to turn it on and off if you wanted to. That, the plus sign at the beginning, I believe that's modifiable. I think, let me double check. I think you can do PS4 is the name of the variable. So I could make this like, 5 greater than signs or something. There you go. Yeah, PS4 is the variable. So if you set PS4, you can change what that prompt is. So you could do like this, so now it looks like we have trace level logging. That's, a pretty cool trick. So I'll just leave that up on screen for anyone interested. GG, thank you. There are still way too many results to go through them all. You'll have to find the LAN party another way and go there yourself. Since it doesn't seem like any employees are around, you figure they must all be at the LAN party. If that's true, the LAN party will be the largest set of computers that are all connected to each other. I knew it was going to be some sort of problem like this. Oh my god. I knew it. That is, for each computer at the LAN party, the computer will have a connection to every other computer at the LAN party. In the above example, the largest set of computers that are all connected to each other is made up of CO, DE, KA, and TA. Each computer in this set has a connection to every other computer in the set. I have to make sure I understand this, but I'll keep going. The LAN party posters say that the password to get in a LAN party is the name of every computer at the LAN party, sorted alphabetically, then joined together with commas. The people running the LAN party are clearly a bunch of nerds. In this example, the password is code kata. Okay. The largest set of computers that are all connected to each other is made up of CO, DE, KA, and TA. So it's 4 computers. Each computer in this set has a connection to every other computer in the set. So this is just a part of the example input that got us there. So, okay. So we went through and we found all the triples. I mean, this is a graphing problem. Okay. I think what's funny about this part is that I can give you a hint, but it won't help since you're in Bash. That's really funny. Don't give me the hint just yet. Even if it changes the way I think about it, I don't want to do that quite yet. But that's really funny if that's the case. All right, let's Vim part 2. What do? We got all them, and we found all the triples. And that took a long time. And I'm sure it'll take a lot longer to find the quadruples. And it will take a lot longer to find the, ones beyond that. So we need a better algorithm. And we don't need a better algorithm. We need a better data structure. We need one of those graphs where we have nodes and edges and we create all the connections between them. That's what we need. Now, how do we get there? We're going to figure that one out together, friend. The nice thing is starting with the letter T is not the important part here. Let me think about this. So if we run part 2 against the example input, we get this. Here are all of our connections. So VC is connected to these 4. QP is connected to these 4. How could we represent this in a way where we can see where they're all connected? Trying to think of what this algorithm would... I'm not even trying to think of an algorithm. I'm trying to think of a data structure that makes sense to store these as, and then what an algorithm could look like to parse these out as. So, I know this is probably really fun for everyone, but I wish I could hook my brain up to a computer and show you what I'm picturing. I'm just picturing how to store each one of these letters and how to draw arrows between them. Like if I were to do this on a pad of paper, how would I do this? Like if I were to write this all on a pad of paper, I'd draw every single possible node in their own spot, and then I would draw lines connecting them. But then how do I determine all of the connections between the lines? Because I could just walk through the lines, but that doesn't do anything. There are ways to do this. There are algorithms to this. I don't know any off the top of my head. Don't say anything. I don't want hints, by the way. Anyone who's new, who's watching, don't give me like algorithm names. Don't give me things like that. That takes all the fun out of it. Don't do that. But you'd have to, there's a couple ways to do this. Once we have all of them connected, once we have all the nodes and all the connections between them, we could pick an arbitrary starting point and we could walk around it. We could just, the same way you walk around like a maze, and we just have to keep track of things we've seen. We have to keep track of loops. We have to keep track of nodes we visited. Yeah, don't tell me about the wham bam shangalang algorithm. Yeah, that'd be cheating. Don't do that. So let's imagine we have this where foo is connected to bar, where bar is connected to baz, and bar is connected to bat, and also these are connected. So we have foo off on its own, but we have bar, baz, and bat all connected to each other. So this would be the solution. Like if this was our puzzle, this would be the solution of our puzzle. So we could start here, and we can see that it only has one connection, and you walk its connection. So we walk all the things connected to it, and we end up here. And then we walk down here. We walk up here. Walk back to here. We've already visited here. So we walk back, we walk its connections. What are we keeping track of? What are we doing on this nice little walkabout that we're having? This is what I'm trying to figure out. Yeah, I think I'm gonna need Shangalang's theorem here. Man, this is where a more recent CS degree would help me here. This is where dealing with these kind of problems on a daily basis would help me, not basic sysadmin stuff. But that's why it's fun to do these. I'm exercising my brain in ways that I haven't had to think about. There's no guarantee that this map isn't completely broken. Like, we could also just have, like, you know, Dave over here not connected to anything that has its own set of connections to, like, Bill. Like, that could also be a thing, and there would just be, like, a severed, you know, connection between these two. Like, that's totally a possible thing that could happen. It doesn't really matter. This is a computer network. Is this not part of your job? Yeah. Stay away from the networking stuff. I'm scared of it. Nah. Just throw each key in a hash and brute force and listen, man. It could be done. It could be done. And if I used Rust, we'd have a better shot at it. Yeah, I need a program. The worst part is I know there's networking programs that will do this for me. Like, I know there's literally, like, I could put this in a format that I could give it to a network program that will run these algorithms on it and give me the answers I want. But I'm not going to do that. I'm going to try and figure out what those algorithms are. Because so far we've been able to reverse engineer most algorithms we need, which is shocking that it's possible. I'm genuinely shocked at my ability to do it, so I don't want to give up now. Especially we're young into the stream. We still have time to really pour our energy into this. Well, the nice thing is, let's talk about some things that we know. We're going to use the example input as our example. The nice thing we know here is every single one is 4, but that means the max is 4. So the largest it could possibly be is 4. It could be less than 4, and we know from the example that it is 4. But the max that it could be is 4, because like the max that this thing is connected to. So we would need, like, if we saw a max length of like 7 here, we would need to have 6 other ones that also had a max length of 7 to be able to accommodate that kind of a grouping. So if we have 4 here, we need to have at least 3 other ones that also have 4, at least 4, in order to make a whole connection of them. So we know that we can calculate an upper limit, is what I'm saying. And then it becomes less ridiculous. But when we're dealing with the real data, there's just a lot. I mean, we're just dealing with a lot here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so each thing, like this dude has 13 connections. Like that's wild. We need a good way of being able to visualize this in a way that makes sense. I'm doing the thing you're not supposed to do when you're dealing with puzzles, and I know that. I'm getting hung up on what I think the solution is going to look like. And that could be a problem, so I do try to pull myself out of it sometimes. But like, I know the problem is this. I know we have to represent it like this, where foo keeps track of all its directly connected neighbors, which we have. And then bar keeps track of all its directly connected neighbors, and they point back to each other, which is fine. And then we can walk. We can just do a nice little walk. But what do we care about when we walk this list? Like if we go breadth first, we can count how many neighbors we have, but we already know that. If we go depth first, we just get to an end path. So we could look through all the possible paths until we hit something. What can we do while we do it? Every time we walk, we can increment a counter so we can keep track of how far away they are. So like if we had foo, I would know that bar is 1 step away and Baz is 2 step away. I would know that Baz is also 3 steps away, so it's faster to go through bar to get to Baz. But I don't know immediately if that gets us anything. I'm also trying to think, keeping like a pool of connections. So let's see. On your schema, there are no connections from root to neighbors. Fix it. Maybe it could help. I don't know what that means. But that's fine. I'm thinking. Just let me think. Yeah, no hints. Yeah, that was teetering on the edge of a little bit too much of a hint. Especially because I know you have solved these before, Tablet Lenovo. So yeah, don't do that. I have to say, Dark Space, sometimes it's nice because, man, I am just so stupid. I think some of these hints just fly over my head. And I have to say, it's very nice that my brain doesn't even understand half of them. So it's good. I get to still experience these new because I'm kind of stupid. Oh, man. Okay. What can we glean from this? Oh, man. Okay. That's true. That's true, we are. Yeah, because right here, in order for these 3 things to be connected, each one needs to have 2 connections. If I were to add a new one over here, Bob, I would have this, I would have that, I would have, an X between them. So now, if we had 4 that were connected, each one has 3 edges. So it seems like we're going in the n-1 of the number of edges we have. Obviously, they'll have more than that, because, bar's also connected to foo up here, which doesn't get us anything. I got it. I got all the plugs. I got all the Ethernet cables. I plugged in all my friend's computer. Now I got to figure out whose computer has the largest connections of things connected to each other. That actually, unironically, it might be helpful if I just picture actual people's computers and I'm networking them up. And how do I figure out who has the largest connected cluster? All right, I'm going to talk about what I have. Let's see. We have a list of every single connection between 2 different computers. We can construct the list of the 3 connected ones, but that took time. And if we go to do the connections of 4, that's also going to take more time, and it's going to grow with every one. It works awesome. Thank you. So instead, okay, if we have like some sort of graph thing, we started a node. I mean, every node could be a starting position, and we could walk from there. And what information do we glean when we walk out of it? We know a score of how far away they are from us. We know who we visited before, so we can see who they're connected to. We know if they get back to us, then we have a connection there. So we can see how many neighbors it has that gets back to us. I'm stuck on this solution because I've done similar work like this with, like in CS, but this was 15 years ago, so I'm literally trying to recall that information. I do remember this. You'd visit a node, you'd pick one at random, and then you would search out from it. I don't remember if it was breadth or if it was depth, so we'll just pick one. I'm not sharing the right thing. So if we start here, and we depth out of it, we go here, 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 come back to here. We already visited it. Go back to here, there's nothing to do. So then we fall back to this one, and now he can go up here. We already visited it. Yeah, see, this can tell you the max path that something could take to get to it, but it could also tell you... So, okay, we have the shortest path to get to something, but we also have the max path. Or we have all the paths in between. So, like, if it takes if we're at Bob, it takes 1 step to get to bat, but it can also take 2 steps to get to bat. And it can also take 3 steps to get to bat. I don't know how to express this. In a way, we're looking for loops. Like, we want loops. When we found a loop, that means we have an interconnected set of... I like this one. This is the best. This is the best hint I've gotten so far. Build a VM lab and run Nmap. I really like that one. That's so stupid. Oh my god. Hook every computer up to a hub. Start a ping every second, and then count how many pings we see at every single hub in a second. That sucks. You took my hint. Oh my god, I'm going crazy. Oh man. Okay. So if we walk around in a circle, circles are good. We want circles, but we need them to be an interconnected star as well. Let's just do depth first search. If we do DFS from foo to bar, to Baz, to Bob, to bat, we know that we took 5 steps to get to bat. And then we back up. From bat, we go back to bar. Nope, can't go there, it's visited. Baz, can't go there, it's visited. Can't go back to Bob, visited. Okay, so it took 5 steps to get here. Then this one, all the rest of them have been visited, and we took 4 to get there. So we know how far away these are, depending on which way we chose to go. So if we do DFS, 1, 2, 3, 4, we did 4 steps. Foo took 4 steps. I don't know if any of this is useful. I'm just writing down. Here's a list of things we know. If we do bread first search, we get to bar. Bar is 1. And then we can branch out to Baz, Bob, and Bat, and that's it. So 2. BFS, foo goes to 2. So the furthest neighbor is 2 away. I don't know what any of this gets us. What if we picked bar as our starting? And we were to do DFS. We'd get to foo, that'd be 1, and that would fail. It wouldn't fail, we'd be done at 1. We'd go to bat, that'd be 1, 2, 3, and then it would encounter visited. So bar could take 3 steps max. What if we were at Baz? It could go from here to here, but then it dies. It could go from here, here, here. So Baz could take 3 steps max. Bat, same deal. Yeah, in order to make 3 steps max, and then it makes it back. It makes it back on the 4th step is what I'm trying to say. 1, 2, 3, and then it makes it back on the 4th step. BRB? Yeah, man. It's all chill. Let's see. Bob could also take 3 steps max. What does this tell us? Does it tell us anything useful? I have no idea. Because let's complicate this. Why not? This also changes. Oh, this changes a lot if I do that. Oh no, foo can't get back to itself. No, foo can't. Foo can take 4 steps and then dead end. This can take 3 steps, loop on 4. Yeah, no, that's actually kind of key. Yeah, we'll get there. Don't worry, I plan on changing this example around. Each one of these, let's redo it. It's so funny. Yeah, I was thinking I was gonna overcomplicate it, but that's probably simpler. Just connect foo to bat. Because now we have a connection of 3 here, but also in that connection of 3, we have a connection of 4 here. So we have 3 and we have 4. We can visually see that super easy. So if we were to do... Baz can take 4 steps, can it? We'll get there in a sec. I'm going to connect them, and I also want to see how many steps they can take, but get back to themselves, because the goal is to create loops here. That's what I'm going with right now. We'll see how this works. Foo. 1, 2, 3, 4. It can take 4 steps and then get back to itself on the 5th one. Bar 1, 2, 3, 4, 5. It's the same thing. They all can just walk in a big circle. Once you get away from your... All right. Let's lock in. What do we know here? What do we know? We know that we want these 4 things that construct the largest connected nodes. And the way we determine that is simple. We just shamalama ding dong algorithm this. If we pick an arbitrary starting point, we know that you are connected to 3 guys. We could also say you're connected to yourself. I'm fine with that. Then you have 4 connections. And there are 4 things in here. So if I jump to this guy and then do a nice little search out from him, I can see that he also has the 4 connected ones. Wait till I start touching files with these names. Oh, you want a tree structure? Get ready for the file system. Oh man, I have to think about this. This is one of those things. Don't even joke about that. Listen, man, I've done it before. This is one of those things where if I just knew the algorithm, I would be able to do it. No one tell me. I'm not asking for hints. I don't want any algorithm names. But I'm just saying, I'm talking out loud. Because basically what I want to do is let's just imagine this algorithm, how it would be. YL is connected to all these bad boys. Let's use example input so it's less to deal with. YN is connected to these 4 guys. I would need to jump in to each one of these guys and make sure that AQ has the other 3. Or I could put its own connection in there as well to start off with. And then I can check that all of these members exist in the other ones. And they might not, because they might not have in common. I have to find the Venn diagram. I have to find the one that exists in both of them. Super honestly, if we gave you the algorithm name, it wouldn't help. I've been programming for 20 plus years and I've never heard about it. You'll get there anyway. Okay, cool. That's good to know. Yeah, no, still no one tell me. Maybe after this thing is done. Like after this challenge, after I finish and get the solution, if people want to give me the name of whatever algorithm I have to search. Like one of the Advent of Code puzzles, people gave me the spoilers ahead. But on the one with the Christmas tree, someone told me after the fact it was, what was it, the Chinese remainder theorem? And I was like, cool, yeah, if you had said that, that wouldn't have done anything for me. I would have been like, oh, okay, sick. Like, it's literally Dark Space saying the Shamalama Ding Dong algorithm. Like, it just doesn't help me, which is good. I like your approach of going it alone. That's how I approach these things. It's more fun that way. Later, I can cheat and look at other solutions. Then I'm more likely to be creative. Yes, I love this way of programming. It's fun to have chat, don't get me wrong, but, like, I like not looking it up, not trying to Google, literally just staring at this and be like, can I make my brain finagle this in a way? Because all problems, this might be too strong of a statement, but like, it seems like all problems can be broken down into smaller problems, and they usually are just an issue of representation. If you can find a way of representing the data differently or gleaning information out of it that wasn't intuitively obvious, you can solve some really, really complex problems. So that's basically what I'm trying to do. I'm trying to picture all these, like, I'm literally picturing computers in my head and connecting them. And how would I put that data out in a way that made sense? Yeah, it's one of these algorithms that goes back to the 50s. That's cool. I think that's super cool. For me, executing step by step of previous solution helped, but it's not universal. Yeah. That's the other thing too. Oh man, I do hate when I come up with a solution that's not universal, where I'm like, yeah, it worked for me and I got the answer. And I know that's technically correct, but like, I want one that works for everything. But sometimes you just don't get that, or not without a ton of work. So, okay, this isn't helpful. Let me stare at a different representation of the same data and see if this is helpful. I did this in an unorthodox way. I think you'll appreciate it when I tell you later. I think I will. I'm excited for that. I'm going to figure this out. I'm going to figure this out right now at this very moment. Okay. What if we bred first here? And then it bred first. Well, no, I'm just describing bred first search. If we DFS, I wonder if learning these terms is screwing me up because all I can think of is in these terms. Sometimes that can be limiting. Learning terminology can be so useful for helping you understand it, but it can also stop your understanding by forcing you into a box when you don't want one. Like, boxing your way of thinking is so useful to make progress, but it can also hinder other progress. It's such a give and take. It's such a, you have to know when to step out of it, and puzzles really force you to drill into a specific situation or step back and get a 1,000,000-foot view of the problem. So here's the edge count. This is neighbors not including yourself. So these are the ones we care about. All three of the neighbors of Cucks? That can't be how you pronounce that word. It's the first time I've ever said that out loud. All right. So bar and bat have one that don't actually matters. So yeah, I called it neighbors. I think edges probably makes more sense. Like foo has, what I'm basically saying is foo has 2 lines coming out of it. That's what I wrote down here. Bar has 4 lines coming out of it. Baz has 3 lines coming out of it. That's kind of what I'm looking at it. And I'm not counting themselves in it. If I did, it's just an off by 1 thing. So it's not a big deal. What does this actually tell us? Yeah, every single, wow, that's a loud plane. Every single one of these just has, and in the example input, they all have the same number of neighbors. So yeah, like I think in the example input, they're all gonna have, yeah, every single one has 4 edges or 4 directly connected neighbors or 5 in the ring of connections if you include itself. I don't know if you'll enjoy it or not. My brain's fried. Our problem right now is our input looks like this. We're at a LAN party and all these computers are hooked up to each other so they can play games together. In this example that I'm using, my sample that I created, we have 5 computers. Foo, Bar, Baz, Bat, and however you pronounce this word. They're connected to each other with Ethernet cables so they can play. So Foo is connected to Bar. Foo is also connected to Bat, and Bat is connected to Bar. So these 3 guys are all connected to each other, which makes they're all connected to each other, and it's 3. So 3 is pretty big here, which is nice. But if you go down here, notice that bar is connected to all of these down here. Bad is connected. This X means that they're connected diagonally. Everything is connected here, but Baz is not directly connected to foo, and QUX is not directly connected to foo. So the biggest group of interconnected computers is this. It is a group of 4 computers, and is specifically bar, bat, Baz, and QUX. These are the 4 computers that are all connected to each other. So bar has an Ethernet cable to Baz, to QUX, and to bat. This is what we're looking for. Visually, this is very easy to spot. But when we have 1,800 computers or whatever the example has, it gets really hard. So we need to come up with code that tells us what's going on here. And you're not a programmer, but if you have the algorithm name in your head, don't tell me. Because I'm trying to backwards figure this out without knowing what to do. So I'm trying to figure out, like, if I start here, I can visit, I know who my neighbors are, I know who foo's neighbors are, I can walk down here, and then what can I do? I can see, like, foo has 2 edges. That's cool, but I don't know if they're connected to each other or not. If I walk the edge, then I can see that bar has 3 edges. Ah, you're trying to get a whole picture, get it? I think you're... Yeah, that's what I'm trying to do. I'm just trying to get a really, really simple sample. I'm not trying to match what the example is or evolving on any of that stuff. This is literally its own solution, or its own description of the problem. So if we start a foo, we know we have 2 edges. That's cool, so we can go down either one. Let's walk down to bar. Bar has 4 edges. That's really cool. We can't go back up. We've already visited there. So let's walk down here. Baz has 3 edges. That's really cool. We can walk here. You have 3 edges. That's really cool. We can walk here. You have 4 edges. That's really cool. We can't walk anywhere else because we visited them. This one is, I would say this one's easier than 21. Absolutely. 21 was mind-breaking. I know I don't have a workable solution yet. I don't even have anything to implement that I could... I have brute force ways of doing it, but 21 broke my brain, dude. 21 is so far out of my brain. 21 was so hard to conceptualize the problem. Just keeping track of it in your brain was hard. This problem's really easy to understand. I have a whole bunch of computers that are plugged into each other. I need to figure out which computers are plugged into the most other computers that are also plugged into each other. It's an easy problem to understand. I just have to figure out how could I even write something that can do that. That's like one of the things, yeah. 21 is the hardest problem this year by stats. Yeah, I 1000% believe that. 1000% believe that. Even the way I got the answer, I wasn't even, like, satisfied with. Like, I got the answer, but, like, still didn't even fully get why. I have to revisit that sometime. Let's do this. Yep, we're gonna get a little bit of a mind shift here. Year of the Bash. Ash knows. Ash understands it. Cool. No one complain about the stream title now that I'm in a different language. No one better complain. I do love Rust. I really do. You single-handedly convinced me to start writing Rust for personal projects. Hey, that's awesome. I am happy to hear that. Can't just return a result. I'd have to context it. Well, whatever. Let's just unwrap it. Okay. Let split equal line dot split. Can I do this? What does this give me? Print line. Doing pretty well. Yo, that's awesome, man. That's super cool to hear. Heck yeah. C for life. Yo, I can respect that. When you split something, what do you get here? Do I just collect it into a vec? Still in bash? Yeah. Tableau Lenovo knows what's up. Okay, this is what I wanted. Cool. Look at how beautiful that is. I'm back. We rustin' nice. Yep. Skill issue? I'm okay with that. That's a fine message. Let connections equal a hash map. Cool. And then we will do connections. I should probably look up the syntax to this. I should probably take the time to look up the syntax for this. I'm gonna give me real quick. Rust hash map default value vec. I should learn how to do this. Like Python has default dict, and I would like something like that. And I know there's a way to do it because you can use the entry, the entry thing. Yeah. Entry or insert. That's it. I used to do HTML on my Neopets page to make it look pretty. Am I a programmer? Yeah, definitely. Listen, yeah. Ash will let you have it. The key, which is SPL0. Or insert an empty vec dot push SPL1. I think we can do that. Yeah, you got it. I don't support someone making fun of Ash. She's one of my mods. You be careful. All right, I think that's working. I'll let you have it. And that it is an apology. I'm sorry. I like that. All right. So now if we print line our connections, you will never solve the problems. True. Cool. So now we have a list of our connections here. Hey, look how easy that is. That's amazing. I'm new here, but you've clearly proven that you're Canadian. Yep, that was the proof right there. Oh, look, everyone's becoming friends in the chat. That's what you like to see. I need to commit this to memory. Entry or insert. Entry or insert. Entry or insert. I have to commit that to my memory because that's super duper useful. So now we have all the connections. And now I can check, loop over each connection, and then check to see the other connections. For A in connections, root, neighbors. Neighbors has 1.0, right? How do I time people out? Don't give her ideas. I wish you could, Ash. I wish you could just time yourself out. Neighbors has a U. Mods, send Ash to the Shadow Realm. Send Ash to the Shadow Realm. Alright, what am I doing here? For each thing in here, I want to see how many of the neighbors share all of these things. So we'll make a hash set of... I don't even know how to brute force this, to be honest. Oh, and we are going to have duplicates, too. Can I do this, or is that, like, weirdly static? Oh, that works. Thank God. Okay, cool. Luckily, I haven't changed any code. I'm just staring at the output. So what I think... We take this, we loop through all these guys, and we get all of their neighbors, and we store it in a hash map, and we count how many times each neighbor is seen. Why do we need a root? I have no idea. I'm trying to figure that out. I'm literally just coding and figure it out as I code, so I can't answer that question. There's not too much critical thought going into this right now. I'm just winging it. Okay, we've seen him at least once. Which I guess is pointless to store that, isn't it? If it's all going to be one. Whatever, it's fine. Not the best code, but I don't care. For neighbor and neighbors, we need the neighbors of the neighbors. Grand neighbors. How do you do this now? You can't do this, right? That can't be valid. Is this valid? That's wild. That's so cool. Okay. So if we're looking at computer DE, these are how often all the neighbors show up. So DE was seen 5 times. I don't know what this shows me. What we're looking for is C, O, D, E, K, A, and T, A. D shows up 5 times. I mean, I can see that the answers are like emerging here. Yeah, I don't know what you're trying to ask, Ash. I mean, if you can reword it, I might be able to kind of make sense of it. Oh, I think I need to see. I think I need to filter out things that we don't care about for the grand neighbors. If grand neighbor in, yeah, if scene dot contains grand neighbor, then we want to increment it by 1. You can do that in 1 line. I mean, that's a little bit of a race condition, doesn't matter. Okay. 5 COK TA. Okay. Now how can we make sense of this? So including yourself, you're connected to 5 things. Including yourself, you're connected to 5 things. And those 5 things are connected to KH 5 times. Those 5 things are connected to TC once. Those things are connected to QP twice. The self one seems pointless. The self one seems kind of pointless right now because it's always going to be 5. So the biggest one here is 4, but we don't have 4 other nodes here. CO, I'm looking at the ones that are correct now. So this one, DE, has also CO, KA, and TA is 3. Yo, what's up, The Bomb? How you doing? So this is a very high number. This is the highest number we see. And we can construct it because we see it this many times, at least this many times. Think back to my hand. I'm not, your hint's always in the back of my head, don't worry. But I don't know if I'm visualizing this in a way that helps. Yeah, I'm getting there. Trying to render a square and failing pretty badly. What are you working on? That sounds interesting. Yeah, I think I want to look for the one that has the highest one in it and start there. So actually it'd be 4 here. But there's not enough here to construct that. Because I would need 4 of at 4. And then I would need 3 of at least 3. Oh, dude. I would stay away from Bevy. It's just too complicated, man. If I'm going to use Rust, I'm going to use macro quad. And if I'm going to use C, I'm going to use raylib. That's my take. I mean, do whatever you want, but yeah. Bevy, you have to learn all of ECS and stuff like that. Count me out. So we're looking at all the ones we have in common. We see the number 4. We can't construct it. We see the number 3. We can construct it. Okay, let's write some logic to do this then. Okay. ECS seems so cool. Yeah, but it's a learning curve. It totally is. So once we're here, we have the scene and the root. We need a hash set of the scene. We need to dedupe the scene. Is there a scene.values? This is not going to be the cleanest code. Yeah. Oh, macro quad's way easier. It's like raylib for Rust. I can't speak to how good it is, like, you know, but yeah. Okay, so now we have that. So now we can, now that we have the list, then can we put them into a vec? Can you just make a vec from a hash set? I have no idea. We're doing this so verbose because I don't know many of the Rustisms. Can you do counts.sort? Is that a thing? No, that wouldn't make sense. Okay, now we have them sorted. We do want them sorted the other way. Does this exist? I'm just making it up. Hey, it exists. That's awesome. I think we want to reverse this hash map. We're almost here. We're almost here. I don't know. I can't speak much for its 3D. I'm gonna be honest. This sucks. Oh yeah, we're in Rust now. Hey. Yeah, no problem. Yeah, MacroCloud's pretty cool. I've had a lot of fun working with it. Okay, so what do we have here? We have the counts, and we have them in reverse order, and then given the counts, we can check, like, we have to find the first viable solution. So in order for 4 to be viable, we would need everything and everything below it. Oh, that sucks. I have no idea what I'm doing. This is some scuffed code, my friends. For num in sorted. I'm very close. I'm absolutely very close. For num in sorted, let subset equals then at num I have to do this, really? How do you Rust push vec onto vec? How do you push a vec? How do you concatenate them? There's append. Oh, there's also extend. Interesting. Oh, we just append it. Okay, so we didn't just say friends dot append subset. This might yell at me. Oh, it needs to be a, well, that's interesting. It needs to be a immutable reference. Nice code, man. Yo, appreciate it. Cannot borrow is mutable. Well, what if I clone it? Then you can. Oh yeah, dude. What, a double reference? Interesting. That actually makes perfect sense that it would do that. No guiding questions. I'm on a roll right now. You 100% do. Yeah, it sucks. If I have time to clean it up, that's the thing. I'm coding fast. If I had time to clean it up, I would think way differently about this code. There's so many ways to optimize it. Yeah, the only reason I'm fighting the borrow checker is because I'm trying to code relatively quickly. So here are my friends. Okay. What does this tell me? Okay. If friends.len is greater than equal to the number that we have, then we found the biggest for this single computer. Oh, yeah, why did I call like an expression? Okay. We have one more place where we're print lining. Okay, so this had 4 friends, this had 4 friends. C-O kata. Well, we know those are the answers, so we're not quite getting the right answer. Something's not quite right with the way I'm doing this. cloning's not necessarily slow in and of itself. It depends what you're cloning. If you're cloning large amounts of data, then yeah, it's slow. But for like small strings and stuff, and computers are relatively fast at allocating virtual memory. Yes, this isn't right. Something with my logic's not quite right. What's up, Warforged? How you doing, man? We're chilling. We're almost done with this. Oh, this isn't... I see. Yeah, there's no guarantee. This is a tough one. Oh, no, it's different. It's this one we care about. Yeah, it's this one we care about. I think we're here. We just have to... Okay. So the one that found 3 friends is the one we care about. Because it's... Yeah. Okay. Let's make a final thing to store the answer. Let mutt. We're just going to do options. I don't care. It'll be an option of a vec of whatever's. And let mutt min equals -1. So now we go here. We found it. If num is greater than min, then min equals num, and answer equals friends sum friends dot clone. Okay. Let answer equal answer dot unwrap. Print line this one. We still have to sort it, but that's okay. It's okay because we literally just do answer dot sort. Okay. Okay. What did I do wrong here? I see what I did wrong. That's not how you make an option. That's how you declare a type. You make an option by setting it. Oh, yeah. Rust. And their sentinel values. No one watch what I'm about to do. Absolutely no one watch what I'm about to do. Kodikata. Kodikata. That's the answer. We got it. And in order to format it, we just join it by commas. Or apparently not. What does this give us? Isn't it join? Does it have to be a character literal? That doesn't implement. That's crazy. That doesn't implement this? What am I supposed to do? No, no other hint. No, we're fine. Sorry, I'm reading messages late. What is wrong here? What am I doing wrong here? Just Rust stuff. I have a vec of a... How did I even end up with this kind of vec? Why can I even call join? Can I do like... This is silly. I mean, I can format it myself, obviously. I could also do this. You literally like map it to s.toString. And then I own everything in there. Oh, it's still an iterator, isn't it? I am not okay. I can't believe I almost got this syntax right perfectly on the first try, because this is gnarly. There we go. Wow. I don't even want to talk about this line, guys. I don't even want to talk about this. For some reason, answer was a vec of a reference to stir data. So I had to turn into an iterator, call toString on every single method inside it, collect it back into a vec so I could call join on it. But we have the answer. I'm going to be real with you guys. I don't know how I would do this in Bash. We are nested upon nested upon nested. I could reverse engineer this and come up with something that would work, but I don't even know if it would work in good time, because I don't even know if this is going to work in good time. It worked really fast. Okay. So, that was way faster than I thought. Jesus, yeah, even development mode runs like this fast. We get the same answer. I don't know if I'm going to try and do this one in Bash. I'm going to be honest. We might just have to leave this one in Rust. Moment of truth, everyone? Moment of truth. Let's go. Let's go. That's the right answer. You are 1 gold star closer to finding the chief historian. Let's go. Let's go. Nailed it. Easy. Done. Oh my god. Easy. Easiest puzzle of my life. I've never seen an easier puzzle. Oh my god. That sucked. That was a ton of fun. We nailed it. Good job, everyone. We crushed it. Day 23 is down. South of 4 hours. Crushed it. We only have 2 more to go. Day 24 and day 25. Yo, Andre, thank you for the $5 super chat in YouTube. Dude, Andre's crushing. Every time I beat a puzzle, he's like, yeah, $5 super chat. Heck yeah, brother. Love it, man. That's awesome. GG. GG. That's it. We did it. We did it. Ash did it. Nice. Nice. Got the intersection of all the neighbors for a node. I did, in a very roundabout way. In a way that was really, really dumb. Yo, appreciate it. Clap. Thank you, brother. Heck yeah. Love it. My goodness. Nailed it.